Okay, so now let us look at this problem. This problem is asking us to find the area inside this Limacon. R equals 4 plus 2 sine of theta. Okay, so this is in polar coordinates. We can, I don't know, so we can draw it. So when theta equals 0, so R equals 4, which is here, right? When theta equals pi over 2, 90 degrees, so it's a 4 plus 2, so it's a 6, something here. When theta equals pi, as you can see that, so it's sine pi, it's also 0, so the R equals 4, but it's in this direction, right? And then when theta equals pi 3 pi over 2, which is 270 degrees, which is right here, so it's gonna be 4 minus 2, so it's gonna be 2, right? But it's in this direction. So, and then when theta equals 2 pi, go back to here. So basically, as you can see, like the graph is going to be something like this. Okay, not in a perfect way, but you get the basic picture here. So that's we want to figure out the area of this in terms of polar. So the area under curve between two angles. So the formula is going to be integral from alpha to beta, so 1 over 2 r squared d theta, right? So back to our problem, it's going to be from 0 to 2 pi, 1 over 2, 4 plus 2 sine theta squared d theta. So if you simplify a little bit, that is 16, right, plus 16 sine theta plus 4 sine square theta d theta, and then that is 8 plus 8 sine theta plus 2 sine square theta, and then d theta. Okay, so that's the problem here. So to integrate this, you see we encounter this sine square root of theta, so we need to use a trig identity. So keep in mind, let me show you some very fundamental trig identities here. So first of all, everybody knows that sine squared plus cosine squared equals 1. And also the other one is cosine of 2 theta equals cosine square theta minus sine square theta. Okay, so you can see that we actually can use the top to substitute this part. It becomes into 1 minus sine square theta and then minus sine square of theta equals cosine of 2 theta. That means what? That means we can solve for sine squared into this way. So it's 2 sine square theta equals 1 minus cosine 2 theta. And then, so you can see that sine squared equals this. Okay, equals this. Well, in fact, actually, what we want is we actually need those 2 sine square theta, right? So which is 1 minus 2 cosine theta. So we can substitute that part into 8 plus 8 sine theta plus 1 minus cosine of 2 theta d theta. Okay, so now the problem becomes into 9, right? Minus 8 cosine theta, right? And then minus sine of 2 theta, and then over 2. That's the integral from 0 to 2 pi. Oh, excuse me. So this should be 9 theta. Okay. So a plus 1 is 9 theta, and so forth here. And then we can do, first of all, sine of 0 and sine of 4 pi is going to be all 0. So this part is gone. So basically we can simplify our problem into this. And that is 18 pi, right? Minus a to cosine of 2 pi. And then minus 9 times 0 minus 8 times cosine of 0, right? Cosine of 0. So, and keep in mind for here is, cosine of 0, it equals 1, and then cosine of 2 pi, it also equals 1. So basically those two cross out. So it turns out our answer is going to be 18 pi. Okay, 18 pi. So that's the first problem.